Hi there, I'm back in Watergate, and was last time I was here. It was actually blowing a gale, and I had to postpone my beach trig antics and go to the decking in the garden instead. But today is a very different day. It's nowhere near as windy. The surf is looking absolutely lush again, but tide's a bit low, so I'm going to go and find a little rock down there somewhere and do a non-calculator trig 3D problem that I stumbled across the other day from one of the higher papers, and then after that I'm going to go for a splash. So cool, let's go on with it. So I've just walked right to the top of North Watergate, so it's about as far as you can go without bumping into the headland over there. I found a nice little spot out of the wind. It's almost like a natural chair, and I'm going to sit down and get on with some a 3D trick problem. Okay, so anyway, I'm waiting for the tide to come up to get in the sea, so I've got a good hour before that happens. All right, let's go on with it. Okay, so I've had to do a voiceover because the wind got too bad and it became very difficult to hear. So it's a situation, we've got a square-based pyramid, and we're told that the diagonal angle AC with the sloping side length EC has an angle of 60 degrees. We also know that the side length is 12 centimeters, and the volume of any pyramid is going to be a third times its base area multiplied by its height. So I'm going to drop a vertical line from E down to the diagonal, making a right angle. And then I'm going to extract the vertical triangle you can see, which is now going to be a 90 degree, so right angle triangle, 60 degrees and 12 centimeters, my sloping side length. So there's my height. And normally I'd label the height H. However, because we're going to be using trig, it could be a bit confusing. So instead I'm going to rub that out, and I'm going to label my hypotenuse as H and my O opposite and A adjacent to the angle. So I can now use SOHCAHTOA, and I'm going to need to know both the base, so I can work out the side length of the square, and I'm also going to need to know the height. So I'm going to need to use SOH and CA, i.e. I need to know the sine of 60 and the cosine of 60. So I'm going to write down sine of 60 and cosine of 60, and I know this from my non-calculated trig that I did recently on a video, that cos 60 or cos 60 is a half, and I know that sine 60 is root 3 upon 2. Okay, quite easy to get those two confused. And now I'm going to use my knowledge of trig to work out my O and A. So I know that O divided by the hypotenuse divided by 12 is going to be equal to sine 60, which is root 3 upon 2. So multiplying both sides by 12, I get 12 root 3 upon 2, or more simplified, simply put 6 root 3. So there's my opposite. And similarly for the adjacent, I know the adjacent over 12 is going to be equal to cos 60, which is a half. So once again multiply by 12 both sides, and I end up with the adjacent is 6 centimeters. Okay, so that's actually allowed us to work out some facts that we need to finish the calculation of the volume. So here we go. Okay, so we're on the final straight. So what I'm going to do is I'm going to extract the triangle I'm shading there, and I'm going to find its height and the base, and then I'm going to extract the bottom triangle, which is half of the base square. I'm going to do some calculations using that. So here's the extracted diagram, just to simplify things. We've got a height 6 root 3, and we've also got a length 6 centimeters, is halfway across the diagonal, so the full diagonal is therefore going to be 12 centimeters. So we'll obviously rub that out and put our 12 centimeters in. And you'll notice that that's the diagonal of the square, and because it's a square, the two side lengths are the same. So we are going to label those in a minute. We're going to label those X and X. Okay. Now we could use one of two ideas here. We could either treat it as Pythagoras, or we could treat it as a trig with 45-degree angles, but we're just going to use Pythagoras. So a squared plus b squared is equivalent to x squared plus x squared, and that's going to be our c squared is 12 squared. So we end up with 2x squared plus, is equal to 144. So x squared is equal to 72. We can find the square root of that, root 72, which is going to be obviously using surds, root 36 root 2 or 6 root 2. But we don't actually need to do that because basically what we need to do eventually is find out the area of the triangle, or rather the area of the square, the base. So we're just going to simply square x, so we can just erase that line and just keep our x squared. So we know that's the base area of our square base pyramid. So all we need to do now is use our relationship for volume, and obviously substituting our height in, which is 6 root 3, and we have everything we need. So our volume equation or formula for any pyramid is going to be V equals a third base area times h. The base area, if it was a cone, would be pi r squared, but in this case you've just got the area of the square, and we just sub everything in. So we do a third multiplied by 72 multiplied by 6 root 3. Now I could find a third of 72, but there's no need to make it difficult. I can simply do a third of 6 instead. So I get 2 root 3, and then 2 times 72 is 144. So we end up with 144 root 3 centimeters cubed. Okay, so lots of interesting maths in there. Some surds, some non-calculated trig, obviously all in a 3D situation in a square-based pyramid. So definitely a tough question, that one. Okay, thanks for watching.